Hello, in this video I'll be introducing polarization. You may recall that light travels as transverse waves. This means that the direction at which the medium vibrates is here up and down, which is 90 degrees perpendicular to the direction that the wave itself is travelling. Polarization only applies to transverse waves. It doesn't apply to longitudinal waves where the vibrations are in the same direction as the direction of the wave, for example sound waves. Light waves don't just travel in one plane. Here we can see two waves from the same source, one's being coloured blue and the other one red, both travelling in the same direction. Both waves are propagating in this direction. You can see that the red wave is vibrating side to side horizontally, while the blue wave is vibrating up and down. If we place a slot here through which only the blue wave can pass, then that's exactly what happens. You see just the blue wave emerge, the red wave has been stopped. This is called polarization. A polarizing filter is made of polymers that absorb light waves traveling in certain planes, and it allows us to turn unpolarized light, where we have light vibrating in lots of different planes at the same time, into a single polarized beam of light. Look what happens here when the polarized beam of light tries to pass through a polarizing filter that's been turned 90 degrees around. So this one here would only allow through horizontal light waves. In this case, there are no horizontal light waves because we've already polarized it to be vertical. So the wave is completely stopped and no more light passes through. Here we have two pieces of polarizing filter, one held in front of the other, both of them in front of a light source. Both pieces of polarizing filter are currently aligned in the same plane, so that the back piece is polarizing the light and the second piece is allowing that same polarized beam through, hence you can see light is passing through the filter. Now the front filter has been rotated through 90 degrees so that it no longer has the same alignment as the back filter. So the back filter is polarizing light in one direction, and the front filter is only allowing light in a different direction through. So the end result is that no light at all can get through both filters. An interesting phenomenon that makes polarization particularly useful is that when light reflects off a surface, it becomes partially polarized. This means that you can wear sunglasses with polarizing filters that will block out that polarized light. For example, in this image here, this mobile phone has a strong reflection in this image here where no polarizing filter is being used. In this picture here, a polarizing filter is being held in front of the camera, and you can see that the light that is reflecting off the screen has been greatly reduced. The reason for that is that as the light reflects from the screen, it becomes polarized, and by aligning a polarizing filter in such a way to block that polarized light, you are able to produce an almost reflection-free image. This is particularly useful for sunglasses because it blocks light that's been reflected off puddles on the road and reduces the glare that a driver sees.